Okay, today's webinar is on best practices for script design. Now, I want to be real clear. This is not best practices for PowerShell syntax. We're not going to talk about how to properly indent your code or anything like that. This is about designing your script. This is almost an exercise that you could carry out on paper. So there's going to be kind of a little bit more slides than I usually like to do, but we are going to get into some specific concrete examples at the end. I have a script that I use quite a bit that actually exhibits both some good and some bad practices. So it'll give us something to look at. Please do remember, you can always find the latest tech sessions at PowerShell.org on our tech session item off of the events menu or using this URL here. You do need to register in advance if you want to attend the live events where you can participate in Q&A, and we usually post the recordings to our YouTube channel in about 48 hours. If you go up and find today's entry there, you will also find this slide deck. And once the recording is posted, that's where that URL will be as well. If you attended the live event, you will not get an email about the recording being posted. You will need to check in. Also, keep in mind that you are encouraged to submit your questions throughout. You can use the chat panel to chat with everybody who's here. But if you'd like to submit a question that you want me to answer, please do that as we go. We do not have a specific Q&A time at the end. I'd rather take your questions as they come in. So just use the questions panel for that, and I will do my best to address as many as possible. So today, again, we're going to be looking at best practices for designing scripts that both leverage PowerShell's native patterns and capabilities and ideally minimize your work. In fact, we have some specific goals that we'll cover, but first, just a little bit of basic information. This is more of a 200 to 300 level webinar. It does cover best practices and patterns for using complex technologies. And I assume that you have pretty solid experience already with Windows PowerShell scripting and programming. You know the syntax. And maybe you're either looking for better ways to design your script, or you're looking for some ways to explain better script design to your colleagues. And we'll try and accomplish both. My general goals when I dive into scripting are really fivefold. First, I want to make testing and debugging as easy as possible. I am not particularly awesome debugger. I mean, I get by like everybody else does. But one of the ways I kind of reduce my debugging load is by writing scripts that are inherently easier to debug. So that's a big goal, as well as maximizing reusability. If I've gone through the trouble of writing something, I'd like to be able to use it in as many places as possible, and so that's a big goal. I also, because I'm lazy, want to minimize programming effort. As much as possible, I want PowerShell to do work for me. And I really do want to conform to existing shell usage patterns. Now, that is not just an abstract philosophical goal. There is a strong, concrete, practical reason for keeping your scripts looking, feeling, smelling, and tasting like a PowerShell command. And it's because someone else who needs to consume your scripts, or someone else who needs to maintain your scripts or whatever else, they're going to have an easier time doing so if what you do already fits the patterns they're used to. And finally, I do have a goal of getting a job done, which means I kind of need to minimize my time overhead. And I need to maybe minimize the overhead that I put on myself. I don't want to have so many practices in place that it actually takes me longer to write the script, because good practices are wonderful and they're worth a little bit of extra time. But if good practices take a lot of extra time, you're simply not going to do them. So there's a little bit of give and take there. There's compromise here, just as almost everything else in IT. So the way I do this is I break down the overall world of PowerShell scripts into two categories. Now, these are names I've come up with for these categories. They're not official things, but I find they work well in terms of communicating what these two different types of things do. First of all, there are tools. A tool is basically a PowerShell command. Now, that might be a function. It might be a native commandlet. It might be something else. Keep in mind that in the PowerShell world, the word command applies to many different things, many different types of command. So a tool does one thing and one thing only. It is not tied to a specific context. If you think of a simple tool like getContent has no idea what you plan to do with the content. Its job is to get it and stick it in the pipeline. There's no particular task that it is tied to. It's just going to do that one thing. It accepts all of its input only via parameters. In other words, getContent doesn't go out to a database and get the names of the files you want to open. All that information comes to it via parameters. Every bit of information it needs to work comes via a parameter. And it outputs everything only via the pipeline. Tools use commandlet style naming. That tells us that they're going to look, feel, smell, and behave like a commandlet. Typically, in our world, unless you're in Visual Studio, typically you're going to be writing advanced functions that will usually be contained in a script module, and that's how you'll produce your tools. Controllers, on the other hand, controllers are what I think of as more the typical traditional VB script. It's a single script. It coordinates multiple tools to complete a process. And that means the controller is connected to a specific process. The controller is producing a report. The controller is automating a business process. It often does not have a lot of logic or a functionality in it. In other words, it's calling on tools to do the individual bits that need to be done. The controller simply provides the logic that connects those tools together for a particular business process. The controller script might not use commandlet style naming. And the controller, because it's tied to a specific context, may accomplish many different things. It might read data from files, it might accept parameters, it might access a database. So the controller is designed to accomplish a specific business level process, and it does so by connecting multiple different tools together. So tools really, for me, break down into three very broad categories, and these aren't hard and fast rules. Just think of them as kind of loose buckets that you can toss things into. The first category of tools is designed to create information that will be used by other tools. And you want to think of command name verbs like get and import and convert from. They don't know what you're going to do with that information once you've got it. They're just going to stick it in the pipeline, which you might then capture to a variable, and they're just going to hope for the best. The next category of tool actually takes some information and either processes it or takes some kind of action. And the verb get here can be appropriate as well, but also set, new, remove, a lot of the other verbs. And the last type of tool takes whatever raw data is in the pipeline or perhaps a variable, and it converts that into a particular form, typically that's designed for human or machine consumption. Think of verbs like export, convert to, format, and out. The trick is no tool should really do more than one of these things at a time. In other words, it would not be appropriate to have one tool that imported a CSV and used that information to go grab data from computers and put that into a nicely formatted HTML report. If there's going to be a script that does all those things, that's a controller that's tied to a specific process, and it would use individual tools that accomplished different steps of that process. The tools themselves need to be very tightly contained. Here's a poor example. This is a very, very kind of prototypical, almost pseudocode advanced function, but you can see there are two parameters here. One parameter is accepting multiple computer names, and the other is accepting a file name. And then in the body of the code, we're checking to see if the file name parameter was specified. If it was, we're going to read the contents of that file and stick them in our computer name variable. This is not a great approach. And it's not a great approach for a couple of reasons. First of all, purely from a syntactic point of view, it seems like you would never use both the computer name parameter and the file name parameter at the same time. Therefore, those should be defined in different parameter sets, making them mutually exclusive so that you cannot use them both at the same time. But even more so, this tool it looks like it's going to go on and do something later. And if its job is to do something like retrieve inventory information or something like that, it should not be going out to a file and getting information. We already have a tool that goes out to a file and gets information. It's called getContent. This tool should just do one thing. It should accept that information via a parameter. So I could pipe computer names to it, perhaps. I could specify them on a parameter. In other words, an improved version of this would have only a computer name parameter, and it would accept values from that from the pipeline so that I could use the existing getContent and pipe data to it. And the reason for that is, in our poor example, if at one point in my life I wanted to get computer names from Active Directory or from a configuration management database, well, this poor example is not really built to be that flexible. This better example is, though, because it doesn't care where its input originally comes from. Whatever you can get into the pipeline, it will take as computer names. So again, the idea of just having your tools do one thing and one thing only, and to work with the patterns of the shell in terms of accepting pipeline input or accepting parameter input, that's the way to go. And it lets you be more flexible in the long run. You don't need to predict in advance where input will come from. So long as it can get onto a parameter or into the pipeline, you'll be able to work with it. That makes you infinitely flexible, a little bit more future-proof. Here's another poor example. This kind of presumes that we've gone through a bunch of information, we've retrieved a bunch, we've constructed a new object for output, and we've put it in $object. Where this example picks up, we're concatenating that object into an array, and at the end of our function, we're piping that array to format table. This is terrible, and I hate seeing this, because it means this particular function, whatever else it does, can't be used for anything else. The only thing it's ever going to do is create an on-screen display, because once that information has been formatted, I can't convert it to something else. I can't export it to something else. All I can do is display it on the screen, stick it on a printer, or stick it into a text file. That's really kind of the three major things you can do with it once it's formatted. So again, this is kind of alluding to a tool that is trying to do too many things. It's going and retrieving some information, but then it is also putting it into a final form. That's two things, and that's one too many. A better example would be to, instead of accumulating all of my output into an array, simply output each object to the pipeline. The job of the pipeline is to accumulate your output. There's no need for you to also do that. This way, I can run my function, do whatever, and if what I really want is an on-screen display, PowerShell is happy to do that for me, but this gives me the flexibility to instead pipe it to export CSV or convert to HTML or any of a number of other commands, including other tools that I write for myself. So again, the idea is to really think about doing one thing and doing that one thing well, and letting PowerShell's patterns do the rest for you. Leverage the other things in PowerShell, like format table, but leverage them outside of your function, not inside. So some general guidelines to think about as you're thinking about that design. If your information could ever possibly come from more than one source, make a dedicated tool to get that information and then feed it to other tools via the pipeline or parameters. In other words, let's take the simple example of computer names again. Well, I just read the computer names out of a text file. Okay, that's what you do today. Tomorrow, you might need to pull them out of a CSV file. The day after that, there might be a SQL Server database. Maybe there's an XML file. You don't know what's going to happen in the future. If there could ever be more than one place for that data to come from, make a separate tool for it. For example, you might make a tool that's import computer names from config-man database. I realize that's a super long command name, but that's why we have aliases. You might have a tool that's import computer names from Excel. Whatever, you're going to make a dedicated tool whose job it is to go get the information and stick it in the pipeline, and that's it. Other tools can then easily reuse that information. They're not all that functionality is not all bundled together. Similarly, if a tool is doing any kind of formatting, or if it's putting the data someplace, like a database or a CSV file, then that is all that the tool should do. Move everything else to another command. In other words, once you've built a tool that is putting something into a final form, that is the only thing it should do, nothing else. If a tool, and this is an important one, if a tool is making any kind of change, then that is the only thing it should do. So if you've got a tool whose verb is set or remove or new or something like that, then all it should do is make that change. It should not go out and open a file to read input. It should not flip out to a database to write output. It should just do that change. It should never worry about where the input came from or where the output is going. The output's going to the pipeline. The input came from parameters, and those are the only options. Because remember, if a tool is one that makes changes, it's supposed to support minus confirm and minus what if. Inside your code, minus confirm and minus what if really are only meant to wrap around one operation within the tool. So that's the only thing that the tool should do, the things that it can wrap a confirm or a what if around. Now, there are some possible red flags. Possible red flags. These are not a hardcore list of things you must never do. These are things that when I see them, make me want to dig in just a little bit more, learn a little bit more about what's happening, and see if maybe it's taken the right approach. One red flag. If there's a parameter set that accepts information, such as a computer name, and in the same function, another parameter set accepts a source of information, in other words, a file name or a database connection string, that's a possible red flag. That means that the function is possibly concerning itself with input and with processing that input, and I might want to break those things apart. Any use of get content inside of a function, unless that function's whole purpose is to read data, that's often a red flag for me. If you're going to use get content to retrieve information, I usually want to use it standalone and then pipe that information to a command that will actually use it. Wrapping everything together is a potential problem. Not always. There are instances where it's the right thing to do, but that's something I want to look at. Any use of format commandlets, export commandlets, out commandlets, or convert to commandlets in any tool that also does some form of processing is a huge red flag for me. Because once you run any of those commands, the output of your function is not going to be good for anything else. I like to break that processing into a separate task from the make this into pretty output type of thing. Strictly when we're building tools. Now, when we're building controllers, that's when your brain shifts. Controllers don't actually have very much work code in them. They instead implement a lot of logic, if constructs, loops. Heck, depending on the type of controller you're building, maybe they're using read host to collect input directly from the command line. Perhaps they're popping up graphical user interface elements if the controller is designed to interact with human beings. They're implementing that logic to decide what work will be done, and then they call commands, tools, to actually do that work. So the controller is responsible for that entire cycle. And this is where I think sometimes people could do a better job drawing a line. Well, yeah, I know I'm supposed to write a tool that only does one thing, but for this business process, what I need is to get a bunch of computer names, and I need an HTML report. Great, that might be 3 steps. That might be get the input, computer names, go gather whatever information, and turn that information into an HTML report. Tools are going to implement a piece of those. The controller is what brings them all together and makes it happen in the right sequence. Automating a process, producing a report, displaying a menu. You know what? A controller script might be the only time I'm okay with you using write host and can I get an amen? Because the idea is a controller might be intended to interact with human beings via the screen. A tool would never be designed that way because you don't know that the tool is always going to be used in that context. Remember, tools don't have a particular context that they're tied to. A controller does. So these controllers use or control or coordinate one or more tools to do something useful. The tools might not individually do a totally useful thing by themselves. The tools do part of a useful thing. It's the controller that brings it all together. So to kind of revisit this, think of new AD user as a tool. It does one thing. It does not complete an entire process. It doesn't provision a new employee. It doesn't add them to any groups. It only does one thing, and it has no idea where the new user information is originating. It could be a text file. It could be piped in. It could be coming out of it. It doesn't know. It's only going to take the information via parameters, and that's all it's going to do. On the other hand, a controller script like provision employee.ps1 might do many things, and it might use new AD user internally, but it also might create a home directory, add the user to multiple groups. This might decide where the information is going to come from, maybe a spreadsheet or an HR database. This might output information to the screen or to a file, maybe a file listing the new user passwords. There's a lot of things that the controller can do, but it's not doing any of the work. It's just connecting all these different things together. Now, in terms of does that approach kind of tools and controllers, does that help achieve our goals? Well, for testing and debugging, absolutely. Because tools can be tested independently right from the command line, and you're going to be using the same input mechanism, parameters, that a controller might use. So you can test them in the exact same way they're going to be used. Because the tool only does one thing, it makes debugging simpler and more contained because there are fewer moving parts to worry about. Controllers, on the other hand, don't do anything. They just make a lot of decisions. It's easier to test their logic, especially if you've implemented things like minus what if in your tools. You can put a lot of verbose statements into a controller to see the logic path that it's taking, and it makes testing and debugging a ton easier. How about reusability? Well, because your tools aren't tied to a specific context, they're much easier to reuse. The same tool you write today that gathers information for an HTML system inventory report might be used interactively by someone on the help desk that just needs to quickly obtain that information from a particular server. That same tool might be incorporated into a GUI that becomes part of a self-help tool. Maybe it gets fired off by a self-service website that's hosting the PowerShell engine. There's a lot of different ways you can use tools if they're not tied to a specific context. And because controllers tend to offer little to no actual functionality, remember the controller's not doing anything, they don't need to offer reusability. So the fact that a controller is tied to a specific context and isn't easily reusable isn't a negative thing, because there wasn't much in there that we would have reused anyway. Everything in it has to do with the specific context that that controller was written for. Now, Rob asks, in your differences between tools and controllers, it looks like tools are commandlets and controllers are PS1 scripts. Yes and no. Maybe a little bit careful. A tool would be a command. That might be a commandlet, which is written in Visual Studio. It might also be an advanced function, which does live in a PowerShell script file. So the container that the code lives in is not what's important. A command would be a commandlet, an advanced function. Workflow is a type of command, so that would certainly be a candidate as well. A controller, the difference is, yes, is a PS1 script, but it's typically not a function. It's just a script. So would I have smaller controllers that might be used in multiple places? Probably not. Simply because for me, a controller is so tied to one specific type of process that that's the only thing it could ever be good for. If a controller is doing something that might be usable in one or more places, then that bit of it that could be used in one or more places should be wrapped up into a tool, an advanced function perhaps. And yes, advanced functions would live in modules because you want them to be easily portable and easily loaded and reused. So this really has nothing to do with the container it's in. It doesn't matter if it's in a PS1 or whatever else. It's if the code is going to be used in more than one place, it should be in an advanced function. And that advanced function should be as simplistic as possible so that it can be called in as many different contexts as possible. So minimize and conform. Tools, whether they're commandlets or advanced functions or whatever else, tools are designed to work consistently with existing shell patterns, meaning you declare your parameters, you use the commandlet binding attribute, you make the thing look and feel like a commandlet. You use comment-based help. You use write verbose as your output. You use write output for your actual output. You make it look like a commandlet. A controller becomes that more traditional shell script. It's glue that just runs a bunch of commands. And if you've done any simple batch scripting, that's a really good way to think about it. A batch script, so a DOS script, typically has very little functionality. It's calling command line tools. They have the functionality, and the batch script really just kind of wraps some logic around those to make them work for a specific process. That's exactly what we're talking about. And controllers are things that you should be able to write more quickly because they don't do anything complex. They're just coordinating existing tools, commands, functions, whatever, that either someone gave you or that you wrote. They're just coordinating those things. You can test those tools individually. So once you start using them in a controller, you really should be able to move quite quickly. So let's take a look at an example. Let's pop out a PowerPoint here and unsleep my virtual machine. Now, what you're looking at is a script that I use a lot in classes. Now, because this script is used in classes, I kind of have to compromise a little bit. On the one hand, I want to do exactly the right thing in terms of building a good modular script. On the other hand, in class, I have limited screen space. I often have to bump the font size up. Flipping back and forth between different files can be difficult for students to follow. So this script is actually a good example for this conversation because it incorporates some good practices and some poor practices. First of all, you will notice that this is just a script. There is no function declaration. It does define some parameters, and that's fine. Some controllers are going to be designed to run as scheduled tasks. This one is. This one's not really meant to be used interactively by a human. And so I want to be able to specify input in a way that's compatible with task scheduling, meaning I need to specify things like computer names from a parameter. Now, if we dig into this a little bit, this is one thing right here. Take a look at this. Because this is outputting an HTML report, one of the things it does is it defines a cascading style sheet. Now, my goal for this was to have the final reports be completely standalone. That means I wanted to use an embedded style sheet instead of referring to an external CSS. That's just a design decision. Different situations will call for different conclusions there. I could have written a tool, actually, a command, an advanced function that output this. That would be one way to modularize it. And in fact, if I was going to write several different controllers that each used the same CSS, it would make sense to perhaps put that into an external file to make it easier to reuse. Now, this next section is exactly halfway between a good practice and a bad practice. What you're seeing here are several functions, technically they're advanced functions, that are each going out, retrieving information from WMI, they're constructing an output object, and they're outputting that to the pipeline. In the real world, each of these functions would live in a module, not inside the controller. That's actually a poor practice, and it's one of the compromises I had to make just to make my class workflow a little bit easier. In the real world, these things would live in a script module. They would be tools. They're commands. I would probably be better off if I added some comment-based help to them, some error handling, if I had them accepting pipeline input, for example. So these should really be fleshed out into complete tools, complete advanced functions that look and work like a real command. So I think I've got 5 of these. 1, 2, 3, 4, 5, 6 of them actually. So all of this is stuff that really should be ripped out and put into a script module. So just kind of take that in your head. Now, somebody's asked for the font size to be bumped up, so I'll go ahead and do that. Starting at line 170, and incidentally, if you're interested in this script, it comes with the Creating HTML Reports in Windows PowerShell ebook, and that's free on scripting, PowerShell.org. So starting with line 170 is where the controller portion of this really begins. I'm going through the computer names that were passed to the controller, and I'm running each of my little, here we go. Get info OS right here, get info computer system. These are the functions that were defined earlier. Again, those functions would ideally live in a script module, not here in the controller script. That way, those functions could be used in other situations, not just this one. So I'm running each of these. And because this is a controller, and the job of a controller can be to arrange for the final format of something, I'm going ahead and converting that to HTML. But look at the line I drew. The functions, let's just take a look at this one here. The functions output an object to the pipeline. That's it. They don't know what I'm going to do with it. I could use this same function elsewhere and decide I wanted the output to be in CSV format, or that I just wanted to see it on the screen. The function doesn't know. It's in the controller that I decide that output is going to become an enhanced HTML fragment. So really, all this is doing is combining a couple of tools together. That's it. This hash table right here is just to make it a little bit easier, so I can pass multiple parameters in a hash table and splat them into this convert to enhanced HTML fragment. The real deal here, I'm just running two commands, two more commands, two more commands. I'm just tying the commands together. There's not actually a lot of work being done here. If the HTML comes out wrong, it's this thing's fault. I can go off and test that separately. That actually does live in a separate module. So that's not defined here in the controller. That one was designed well. So I execute all these things, and then at the end, I bundle up a bunch more parameters, pipe it to convert to enhanced HTML, and because this is a controller and it's tied to a specific context, I out it to a file. I want you to think about something though. I'm gonna do something terrible. I'm gonna break my script just a little bit. I'm gonna take away all of my parameter definitions because these do make the script easier to read, but they also make the script look functionally larger than it actually is. If you take away those parameter definitions, now let's pretend that I've moved my functions off to a script module. This is really all the controller is doing. It's running some commands, and that's it. There's no functionality being implemented here, none whatsoever. It's simply running commands, and it's doing something with their output. It decides where the input comes from, it decides where the output goes, and it's running commands. That is literally it. Everything else that was in here was just supporting functionality for that. So, if I put my parameter definitions back in so that it actually works, it makes it look a lot longer, but the real functionality here is being done by commands. So I've separated the functionality from the presentation. The input is decided by the controller. The functions, the tools, they do the job. The output is decided by the controller. So if you think about when you sit down at the shell interactively and you run a command like get wMyObject. Where's my arrow? Get wMyObject. That's the tool. Okay, well, what wMyObject? Well, let's just grab Win32 BIOS. Let's get it from, whatever computer. And by the way, I want to format that as a table. I, a human being, am the controller. I have decided what the input is, and I have decided what the output will be. When you start writing scripts, just make sure that you're separating those two things. The controller decides what work is being done, but it doesn't actually do the work. I'm not sitting here at the shell hand coding the commands necessary to retrieve information from WMI. I have no idea how to do that. I'm running a tool that knows how to do that, and that tool has been tested and debugged by someone else, Microsoft in this case. So think about that division. Chris asks, in earlier talks, I would often gather information from multiple WMI calls and create a custom object containing this data. Is this no longer valid and do one thing? No, that is completely valid. The reason I'm running multiple WMI calls here, multiple functions, is because I want my report to have multiple sections. So if you think about one object being one table, I don't want a single table that shows computer system information and disks and processes. That would be a really jumbled display. So I do, in several cases, I'm not sure if I did it with any of these because I think I kept these functions simple on purpose, but I would be completely fine, say in InfoOS, I'd be completely fine having this make multiple WMI calls and consolidate that information into a single bit of output, provided all of that output was intended to go into one place. That's still a completely valid approach. In this case, I just wanted them in separate tables and separate hunks of HTML, and so I kept them separate. So again, this is just about design, and it's designed for a reason. It's not designed just because I say this is the right way to do it. It's designed because this makes your debugging easier. When I have a problem with this function, particularly if I had defined that in a script module, it's really easy for me to test that thing by itself. Once you start lumping a bunch of code into one script, I mean, look at this script. This doesn't even do all that much, and it's what, almost 250 lines long. Once you start slamming a bunch of functionality into one file, it gets a little harder to debug bits that are broken because you have to figure out where it's broken, and then you have to do breakpoints and start stepping through the script. It just takes longer. But this is only a dozen lines of code. That's easy to debug by itself. And so that's one of the real goals here. Better reusability, yes, but think about how much easier it makes your debugging and testing process when you can do these things in tiny, tiny, tiny little hunks. Much, much simpler. So that's kind of the end. Let's, where's PowerPoint? I think that's all I really had to cover. So if there's any last minute questions, I definitely want to take those. I'll give you a couple of minutes to chunk those in there. I want to talk just a little bit about, while you're thinking, if you have questions, I want to take just a minute and talk a little bit about kind of a bigger approach to this too. I do believe that your tools, your things that do work, should go into script modules. Every organization is going to have a different strategy for how you share those script modules. Some folks have a need to share things in a way that's accessible when they're not on the corporate network, meaning you're going to have to come up with a way of deploying those to everyone. Some folks need tools that only need to be accessible while on the corporate network, meaning it's easier to just stick them in a file share. There's lots of different approaches. None of them are right. None of them are wrong. They all meet different needs. Think about organizing your script modules both around tasks. So, if I have a whole bunch of functions that are going to go out and retrieve inventory information, those seemed like the type of things I would lump together into a script module. Maybe it's my inventory script module. Those things all kind of work and help accomplish the same task. But also by use case. If there's a bunch of modules, or functions rather, if there's a bunch of functions that I need to make available to my field engineers who aren't always going to be connected to the network, well, those things might want to live in one module. I might have other things that are only used by folks at the corporate office who are connected to the network, and those functions might go into a different module so that I can share those two things in different ways. So again, as you start breaking things down into functions and really focusing on creating tools and separating that from controllers, start thinking too about how you're going to present that information to the people who are going to use it. You'll have to come up with, hopefully, change control mechanisms. So when people make changes, they can check things in and out. You've got past version history. You'll have to think how you're going to deploy and distribute the files. And again, there's lots of different approaches people come up with for different scenarios. So I'm going to go ahead and wrap us up. Thank you for all for dropping by. Hopefully this was a short little breakout of your day and you picked up some ideas. Do remember that you can find the latest tech sessions at this URL. We do require advanced registration if you want to attend the live event. I will get the recording posted to YouTube, usually within 48 hours. That link will appear on the event page for this event on PowerShell.org. And if you have any follow-up questions you'd like to ask, please visit the Q&A forums at PowerShell.org. There's lots of people there who can offer different perspectives, different insight. I encourage you to do the same thing too. Even if you're just offering a different opinion on something that someone has asked, that's valuable information. Obviously, mine is not the only perspective out there, and it's by having that larger conversation that we can all sort of change our perspectives for the better in the long run. So thanks very much, everyone, for being here today, and I hope we will see you next time. Our August tech session is going to be creating and testing custom DSC resources. It'll be led by MVP Steve Murawski. I think it's going to be awesome. That schedule is posted on PowerShell.org. You will want to sign up for it. We do have a 100-person limit in the room, and that might well be a topic where we hit that limit. So you'll want to make sure you not only register for it, but make sure you jump in early so that you can save your spot. Thanks a lot, and have a great rest of your day.